Hi ladies, today we're going to talk about circles. We're going to combine two sections, sections 11.7 and 11.8. In particular with circles, we're going to focus on circumference and area. Let's just go ahead and draw a circle and label its different points. Okay, that's not so bad here. Just do your best with the circle. Okay, so this is supposed to be a circle. Here is what is called the center of my circle. And with the circle, we talk often about its diameter and its radius. So the diameter, I can draw this, it's a straight line that goes through the center of the circle, okay, connecting the opposite sides. And the radius is half of that. So we could, in other words, say that the diameter equals 2r, 2 times the radius. Or we can say r is the diameter divided by 2. The circumference of a circle is the distance around the circle. So circumference is equivalent to perimeter. Think of it in those terms. Okay, so the perimeter is the distance around a shape. This is the same thing. The only difference here is that with a circle we don't have vertices. So let's go ahead and talk about that, the circumference. Basically in every circle, the ratio of the circumference to the diameter is equal to 3.1415926, which you guys know is pi. So we could say that if C represents the circumference, C divided by the diameter is equal to pi. Instead of writing it this way, however, we usually write it as a formula in terms of solving for the circumference. So we can say that the circumference is found by taking pi times the diameter d, or we know that diameter is equal to 2 times the radius. The circumference can be found by taking 2 times pi and the radius. So either equation will work to find the circumference of a circle. You guys have pi buttons on your calculators, so on your graphing calculator. Just to point it out, instead of just using 3.14 as an estimate, you can use the pi button. And if you look, it's actually above your little caret button, which is below clear. So go ahead and locate that on your calculator. You'll see pi, whoop, right there. So you'll need to hit second and then the caret in order to get pi. But that way your answers will be more accurate, so please use that. Now I would like to go ahead and review how to find the area of a circle. So to find the area of a circle, if you remember its formula, you can write it down. But this is what it is. The area A of a circle in square units, remember we're always in square units when we're talking about area, is A equals pi r squared, where r is the radius. Okay, so that should look familiar to you. And again, let's just make a note. Use square units to describe area. Okay. In the textbook, just so you know, they do talk about area of sectors of a circle. We are not going to be getting into that right now, so if you see those types of problems on the extra practice worksheet, you may cross them out. Now I would just like you to practice, so please get out your handout, and on page 44, we will start there. Flip my page here. Okay. I would like you to go ahead and complete numbers 1, 2, 7, 8, 9, 17, 18, and 19. So a lot of practice. less note-taking. When you are ready to see the solutions, you may go ahead and unpause. So with number 1, the solution is 56.5 meters. Number 2, the solution is 53.4 feet. Again, that's a 3. Number 7, the solution is 26.7 meters. 8 is 69.1 yards. Number 9 is 20.1 feet. With number 17, let's go ahead and take a look at that one together. So in bowling, the distance from the foul line to the head pin is 60 feet. So if you can picture a bowling lane, here are all the pins. And there is a line that you can't cross, where you're winding up and you throw the bowling ball and it goes do. So we're talking about that distance, and it is, as we said, 60 feet. We are told that a bowling ball has a radius of about 4.3 inches. Now I know a bowling ball is a sphere, okay, but if you take a cross section of it, if you cut it down the center, you do in fact get a circle. Okay, so that radius r is equal to 4.3 inches. It says, how many times must the ball rotate in order to strike the head pin? So how many times does it have to go around before it hits that head pin? So you need to visualize it first to understand what's going on. And we need to think about what's happening as this bowling ball is rotating. As it's going around, okay, we can recognize that it is in fact going the distance of its circumference with each rotation. So each rotation equals one length of circumference. So it would be very helpful to figure out what the circumference of this slice of bowling ball is. Circumference, remember, is equal to pi times diameter, or 2 pi r. I'm going to use 2 pi r in this case because we know r is 4.3 inches. And that will give us the circumference. Now when you type that into your calculator, obviously you'll have to round at some point. And I would say, I think you get like 27.07017 ... Always just do your best. I might round to the nearest hundredth in this case, just to make sure that my final answer is as accurate as possible. But I would accept answers that are off, by a tenth or a hundredth, something to that degree. So how do I use this information for circumference? Well, I know that the circumference is equal to about 27.02 inches. We need to focus on that. And I know that the distance this ball has to travel is 60 feet. So first things first, it would be much easier if I was talking apples to apples. So I might convert 60 feet into inches. Now remember, how do we do this? Well, we can set up dimensional analysis, okay, or you can just recognize that there are 12 inches in 1 foot, and you can just multiply, but this is how, the units cancel out. You'll do 60 times 12, and that would give you a distance of 720 inches that this bowling ball has to travel. And now I can go ahead and divide 720 by 27.02. And again, we'll have to figure out, about how many times that this bowling ball will roll. So you may use a calculator. 720 divided by 27.02, we get something in the neighborhood, of 26.646. Okay, so I would say, about 27 times. Again, depending on how you rounded, maybe you would have gotten something closer to 26. That would be okay as well, as long as your work, supported it. So that's how many times this bowling ball would have to rotate before it hit the head pin. Oops. There's no easy way to erase that, so I'm just going to leave it like that. Okay, number 18. Let's go ahead and take a look at this one. Here you have two half circles on either end of a rectangle. You want to find the perimeter of each figure. So we are not finding area, we are finding perimeter. So if you found the area, just double check yourself. You can use the fact that in the shape they give you, basically the diameter as 11 inches. So you can use that to find circumference. Just remember that you have two half circles. So you could either find half of the circumference plus the rectangle plus another half of the circumference, or you could recognize that this circle, when put together, would give you, the whole circumference. So you just need the circumference of one circle, and then you can add in 16 inches here. So yeah, even with the rectangle, you are not using the 11. Okay, because we just want this distance around, total distance around. When you do that, you should get 66.5 inches. Okay, so that was just a quick little explanation. Let's go ahead and take a look at number 19. Okay, so with number 19, again we have another unique shape. This is a cone of sorts. We want to find the distance around. We are given this length here, which would be the diameter of the half circle. And we are given the height here. Height equals 15 centimeters. And again, we need to find the perimeter, the length around. So there are a couple things we need to do. First, you need to go ahead and find the kind of half circumference of this half circle that you're given. So circumference is equal to 2 pi r, or just pi times diameter. And in this case, we're going to cut it in half. Okay, we'll calculate that. And that gives you about, we'll say 15, maybe 0.7 or 0.71. What units are we in? Centimeters. Okay. To finish this up, this is actually tricky because we haven't talked about this just yet, but I can go ahead and talk about it here because I'm sure you're looking to see how to do this. You might be wondering how you're supposed to find these lengths. We can use what's called the Pythagorean theorem to do this. With each of these figures, I basically have two right triangles, so I'll just explain it to you now. Okay, and the length of, let me flip my figure, looks like this. Okay, it's like this. So two right triangles, each with a base of 5 centimeters and a height of 15 centimeters. And basically I'm trying to figure out what the other side happens to equal. I know that this length is about 15.7 centimeters. So the Pythagorean theorem states that in a right triangle, the legs, I'm going to call them a squared and b squared, are equal to the hypotenuse squared. So if all this is looking like a little bit of gibberish, that's okay. You can fast forward a little bit. We'll come back to this concept, but for those of you who are kind of into it, you can follow along. So 5 squared plus 15 squared should equal c squared. When we go ahead and calculate that, we get 250 is equal to c squared. To undo a square, we actually square root, and we will go ahead and get about 15.8 for this length here. This is an isosceles triangle, so I can go ahead and label that. And now we can actually find the perimeter. So sorry, I didn't mean for this one to be too difficult, but that's okay. You add everything up. Whoops. And you should go ahead and get a perimeter of 47.3 centimeters. But again, if this one was a little bit beyond you, that is okay. On page 51 on the back, I would just like you ladies to go ahead and do numbers 1 and 3. And then you can pause, hit unpause when you're ready to see the solutions. Whoops. Okay, so with number 1 on page 51, you should get an area of 19.6 centimeters squared. And with number 3, you should get an area of 265.8